The vernier caliper. The vernier caliper is a device that can measure to a precision of plus or minus 1/10 of a millimetre. As these jaws move, you'll notice this probe also comes out, like this. These are the external jaws for measuring the external dimensions of objects. To measure internal dimensions, we can use the internal jaws here. This is the main measuring scale. This is the depth probe for measuring the depth of holes, and this is the vernier scale. Here we have a close-up of the main scale and the vernier scale to see how they work. Well, here we have a distance of 9 millimeters. You'll see this starts at the 1 and ends at the 1.9 here on the main scale. And there are 10 divisions. So each division is 0.9 of a millimetre long. If we look at this point here, this gap between the vernier line and the main scale line at 1.1 centimetres will be 1 millimetre minus 0.9 millimetres, which is a gap of 0.1 millimetres, the 1/10 of a millimetre. This gives a difference of 1/10 of a millimetre between the main scale divisions and the vernier scale divisions. If the calipers are open to 10.1 millimetres or 1.01 centimetres, these two lines here would be aligned. Here we have the scale again, and a further opening of 0.1 millimetres brings this second vernier line into alignment with one of the main scale lines. To read the vernier scale, we simply find the measurement on the main scale just to the left of the vernier scale, the reading which is to the left of this line here, and this gives the measurement to the nearest millimetre, 10 millimetres or 1 centimetre at the moment. The number of the most closely aligned vernier line gives the nearest 1/10 of a millimetre, as we'll see in these examples. In this case, the 1.1234 centimetre line is the one that is closest to the left of this vernier line. So this is the 1.4 centimetre line, so our measurement is 1.4 something centimetres. See that this is the most closely aligned vernier line with one of the main scale lines, and this is the 5th line, meaning this relates to 0.05 of a centimetre, 5/10 of a millimetre. So therefore our measurement is the 1.4 plus the 0.05, giving 1.45 centimetres. Here's another example, and now we have 2.1234 centimetres as the main scale line to the left of the first vernier line, and now this is the most closely aligned vernier line with this line on the main scale, and that is the first line, meaning it relates to 0.01 centimetres or 1/10 of a millimetre. So our measurement is 2.41 centimetres. In this case we have 3.1 something. 3.1 centimetres here is the line to the left of the first vernier line, and now this is our most closely aligned vernier line, lining up with this main scale line, and this is the 8th line, meaning 0.08 centimetres, giving a measurement of 3.18 centimetres. Just a word of warning: if you can measure more than 10 items in a row to a precision of plus or minus 1 millimetre, this will give a smaller uncertainty than a vernier caliper. For example, it would be more accurate to measure the thickness of a sheet of paper by measuring a ream of paper with a metre rule than it would be to measure one sheet with a vernier caliper.